So first of all, I will start by apologizing because I went behind Ali and changed the content of my talk a little bit. Even though I know the title says C2VSim update, and mostly I'm going to talk about C2VSim. Since we have two full sessions on C2VSim, we talked internally, and we basically decided that I'll give you essentially an update on CWEMF as an engine, some of the updates, the related tools, and I'll talk very briefly about C2VSim status and set the stage, try to set the stage for the rest of the session, or actually the two sessions, instead of risking repeating the same things that other presenters will talk more in detail. All right, so again, I'm going to start with some of the development status on CWEMF engine. Over the last year, basically, I think the biggest improvement that we have done to CWEMF is now we have these what we call Z budget outputs. For those of you who are familiar with mod flow, these are called zone budget. Originally, we only had zone budget output for groundwater. But now we have the zone budget outputs for all hydrologic components: root zone, land and water use, unsaturated zone, including the groundwater. So the idea is that especially with the Sigma, with C2VSim, we are basically talking about providing fine grid C2VSim to the GSAs. The idea is that the GSAs can come in with their boundaries, their polygons, whatever they are. They can basically clip their interest area from the C2VSim fine grid and look at everything in that area, not just groundwater, but everything, water demand, root zone component, unsaturated zone, all the way from the land surface down to the groundwater. One good thing about these new outputs is that they have much more detail compared to budget outputs. Just to repeat, for those of you who are not familiar with this terminology, budget outputs are for areas, zones that you define before you run your model. Okay, so those are basically static. You define your subregions, your pre-zones, and budget, when you're running your model, accumulates the flow information and prints those out. Zone budget, on the other hand, is more dynamic. The model basically prints out the flow information for each cell, and once you run your model, you basically have the flexibility to group the cells in different ways, however you want, and look at the water budget in that sense. So for zone budgets, compared to budgets, we have much more detail now. For instance, when you look at the budget file for, let's say, root zone, all the agricultural areas are lumped into one single, group called agricultural, right? And you look at the flow balance for the whole agricultural area. Now in the zone budget, we separate that. You can now look at the non-ponded crops, the water budget for non-ponded crops separately, with then rice, refuges, urban lands, and native vegetation lands. So we have much more detail in these zone budget areas. Models are getting bigger, much more refined. The output files are becoming very, very large. One of the models that I'm testing, the CWEMF, it generates zone budgets. The size is around 60 gigabytes. So it's a lot of work, trying to write this data and also read the data. So we've been looking for an efficient database, and we found the HDF5 database, which is developed specifically for scientific data, essentially for matrices. NASA uses it. A few other agencies use it for, again, distributing large sets of numbers. So we have been now basically using this HDF5 format, which is basically transparent to you, the users. We have the tools to extract data from these HDF5 files into text files or into Excel. Another development that we have worked on is the ability to link multiple groundwater nodes to a single stream node. Again, the models are now getting more and more refined. We have a model, Linda Bond, I think, is going to talk about it tomorrow, maybe. It's called SVSim, Sacramento Valley Simulation Model. that model, one of the main interests of that model is to capture the stream aquifer interaction as accurately as possible. So they really refine the grid along the streams. So what happens is when you look at, let's say, a Sutter bypass, this is a little area from Sutter bypass, you have this huge channel with a lot of groundwater nodes along the channel. So the idea is that, well, okay, if I have multiple nodes or cells within the channel, how can I capture stream groundwater interaction? So now basically what we did is now you can list all these nodes and link them, these groundwater nodes, to a single stream node, and we basically calculate stream groundwater interaction at multiple nodes linked to one single stream node. In our experience now, trying to calibrate C2VSim, SVSim, we have found out that, we already knew that rice areas are very, very sensitive to saturated hydraulic conductivity in terms of calculating the demands. So what we have noticed is that we were having problems with cells that are partially covered with rice areas. So originally, when you specify the saturated hydraulic conductivity, you saturate for soils, root zone component, you basically specified that hydraulic conductivity for a single element. And that hydraulic conductivity was being used for all sorts of land use areas in that. No, I don't. Yeah, thank you. So basically, what we were running into problem because for these cells that are partially covered with rice, but with a single hydraulic conductivity, we had to figure out, okay, what kind of a hydraulic conductivity are we going to use? Are we going to try to capture the water demand for the non-ponded crops, or are we trying to capture the water demand for the rice? So we had to basically come up with these pseudo crops and do all sorts of funky business, trying to get the water demand right in this one single cell. So to avoid that, what we now are allowing the user is to specify a hydraulic conductivity to override the entire cell hydraulic conductivity, but just for the ponded area. So this way, we don't have to worry about pseudo crops that basically represent partial cells that have partial rice. And like you might think, oh, it's a small detail, but it's amazing how like just a few cells with the wrong hydraulic conductivity increases the water demand so much. When you have rice, and basically you find yourself trying to find what is causing that. Some other improvements or future developments: water quality module. It's part of Sigma, and we have been constantly getting calls and emails about if you're going to have water quality module. So that's basically coming up, hopefully, sometime soon. We want to improve the subsidence package. Again, one thing with these models now, they're becoming bigger and bigger and bigger. Our run times are, becoming higher. When we first started working with C2VSim 15 years ago, we thought 15 minutes was a long run time. Now, if you get a 1 hour run time, we think that it's a fast model. So we are basically looking for improvements in the code. We are working with UC Davis computer science department to look at the code itself to see if we can find any bottlenecks. And that work will also lead towards a parallel processing effort. So we're basically trying to get every possible speed up we can. Another thing on the works is this IWFM programmer's manual. Several people have asked me if they can wrap IWFM or C2VSim with their own code, like Python, .NET applications, and whatnot, so that they can interact with the model. The idea is that you basically start the model, you run it for a little bit, you pause it, don't kill it, pause it, and interact with it a little bit. Maybe exchange information, maybe overwrite some of the time series data that you have in C2VSim or any IWFM model. So that interaction basically happens at the code level. Back there, there are people who are interested in getting the information for hydraulic conductivity, whatnot, for their graphical user interfaces, interaction with swap, statewide allocation program. So there's an interest in interacting with C2VSim or in general IWFM at the code level. So the manual is coming up, hopefully soon, within the next few months. And for those of you who are interested in, again, interacting with the models at code level, that should be helpful to you. In terms of data development, visualization, and analysis tools, we have the land use extrapolation tool. Again, just to remind you, in the old days, in pre-IWFM 2015 days, we basically dealt with water demand and land use simulations at large subregions, right? Like which were basically multiple cells. But now we are dealing with these simulations at element level, which means that you have to come up with land use, however many different types of land uses you're simulating at each element level. The question is, well, if you have a model like C2VSim, for instance, simulation period is from 1922 to 2015, how do you come up with element level land use going back all the way to 1922? If you look at the GIS data that is available for land use, they're very sporadic. Like this is, for example, an example for Yolo County. If you go to DWR's land and use website, you'll see that there's GIS data for land use for Yolo County for 1997 and 2008. The question is, how can I take this information for 1997 and 2008 and then fill in the years in between for each of these elements for land use? So basically, we have updated our land use extrapolation tool, which we have had for a while, and made it a little bit more flexible. Now you can basically use all sorts of different data, DWR land use surveys, land IQ data, cropscape, and also local data sets such as Kern County's own land use data. This is available for download from IWFM website, and currently it all works from text files, but we have plans to turn it into an automated GIS tool as well, so that you can effectively do your land use development. Our IWFM Excel add-in, it has been around for a while, but we have updated it. What you can do with this tool is, as I said, when you run your RWFM model, it generates this HDF5 files, which are essentially binary files. You can't just open them with a text file and look at them. So this tool basically allows you to point to these files, HDF5 files, and it will basically pull out all the information that is in that HDF5 file. It will know how many subregions you have, the simulation period, the types of data involved. And so basically it allows you to quickly pull the data from HDF5 file and put it into Excel for you to quickly do additional analysis. You can also aggregate the data in time on the fly, which I personally find it very useful. Same thing with the Z-budget data. Very same idea. You point to the HDF5 file. The tool pulls all the information that is stored in that file. And then you also specify your zones. You can specify it either as a text file or within your Excel. So basically, you match your element level data with your zones, and then the tool basically aggregates that information both in space and time, and then imports it into Excel for you to do further analysis. Water budget dashboard. This is something that Abdul Khan worked on, and I think it's pretty much finalized, right, Abdul? At least this is a draft. Pilot project, yeah. So the reason why I'm showing this is because, if you've ever worked with C2VSim or any IWFM model, there's so much information and there's so many different angles to look at the same data. And we have been, personally, I have been struggling to think about like what is the best visual way, like graphics and whatnot, to present that information. And after Abdul finished up this work, I really liked the graphics, the way the information was presented. So we have been, as some of you might know, we have been working on this IWFM ArcGIS graphical user interface. So what I would like to do in the next year or so, basically improve this graphical user interface and then build more or less the same visual tools that the dashboard has, so that they will both have the same feel. So basically, that's why I was showing you that dashboard. The GUI itself is model independent. Again, you point to the text files, and the tool, the GUI, will basically bring everything up, create GIS files, and then you can then basically on your maps you can click on different features, subregions, streams, and it will know what type of information is available for those features, and you can basically generate charts. And one thing that we want to do is to include a scenario comparison tool rather than just simply charting some graphs. Okay, so that's basically IWFM and related tools. Now going into C2VSim model development. These are the contributors. Again, C2VSim is a really big model. It takes a village to develop it, and we've been working on more than 15 years now. So in this current iteration, these are the people most active in this development. DWR, lots of people from DWR. Woodard & Curran is basically our consultant leading this effort. David's engineering is involved. SSPA is involved, particularly with the pest iterations. And again, many people that got involved over the last 15 years. So I just wanted to acknowledge them. Again, as you know, we have two versions of C2VSim, a coarse grid and a fine grid version with different uses in mind. So our initial idea was that, well, coarse grid is quick, it runs quickly, so why don't we start calibrating coarse grid first, and then we're going to basically migrate that data into fine grid, and we're going to touch upon the fine grid. So basically, again, we started with the coarse grid calibration about a year ago. We migrated all the information from the old IWFM engine to the new engine. We updated our time series data, extended it to 2015. If you remember, our old C2VSim ran up to 2009. Our aim is to extend it to 2015. We developed element level land use information from 1922 to 2015. Before we were simulating 14 crops. Now we're simulating 20 crops, which is consistent with DWR's water plan. And we started calibration towards the end of 2017. But because of the timelines that were being pressed for the fine grid, particularly for the Sigma, we had to abandon that calibration, and we switched to all our efforts essentially to fine grid calibration. But currently, the expected release is for this coarse grid C2VSim is the end of 2018. Okay, coming into the fine grid, same thing. So I have these bullets here, and each of these bullets pretty much is going to be a talk in this session and in the C2VSim second session on Wednesday morning. So basically, we migrated again all the files to IWFM 2015 engine, developed the time series data all the way to September 2015. Again, 20 crops consistent with the DWR water plan. We have worked on, or Tyler painstakingly worked on element level land use development, which he's going to talk about, I think, on Wednesday. We also tried to make sure that our diversions and deliveries are consistent with calcium 3, because anytime you kind of look into the future climate change scenarios, calcium always come into picture. You have to somehow figure out what the boundary surface inflows are. So we are trying to make sure that multiple tools. One of our goals in this calibration is not just simply support Sigma, but also to make sure that different DWR tools are consistent with each other. So basically, we make sure that our diversion and delivery locations are same with calcium 3. And we started with the IDC component of C2VSim, or the root zone and land surface component. So in terms of calibration, so that calibration is done, and we spent quite a bit of time on that. And then we basically now are working on the aquifer parameter and stream bed parameter calibration. For the aquifer, we use texture data analysis for the aquifer parameters. We are using PEST for the calibration. And again, as I said, we are now currently working on calibrating the aquifer and stream parameters for C2VSim fine grid. Okay, so again, here's an excerpt from the regulation, Sigma regulation. As the department, we are expected to provide IWFM and C2VSim to anybody who wants to use it for their GSP development. We think that it's a valuable tool. You can look at historical water budgets as well as projected water budgets, which are both requirements under Sigma. And you can also quickly repurpose C2VSim to look at different projects and management actions and their impacts on the hydrology. And we have some funding from the Sigma group to do, to contribute to the calibration, so that we can actually push it out a little bit earlier. So currently we have what we call an early release, a pre-calibration release. We got several requests. People are they understand that it's not calibrated yet, but they want to familiarize themselves with the model, so they want to have access. So right now you can go to the Sigma's website, and you are able to basically sign a user agreement. And then download the model in its current state, uncalibrated state. And the idea is that you're not supposed to do any studies and create, develop your GSP with that, but basically to familiarize yourself with the model files, different interactions. So that's available. Our goal is that we are going to have a beta release towards the end of this year. With a limited documentation, and the GIS files will also be available. I mean, the whole data files will be available, but GIS files will also be available. I'm hearing that there's quite a bit of interest from GSAs to be able to get the GIS files so that they can poke around. And our expectation is that our final release will be sometime, towards the end of 2018, fall 2018, with full document as well as showing the calibration metrics and results. How am I doing on time? Good. Okay, I'm almost done here. And finally, some contacts here. Myself and Tyler. I'm more on the technical side. If you have any questions about why C2VSim is not running, probably that would be me. For Sigma-related issues, I think Tyler is the person, Tyler Hatch, to contact, and we have some resources. Again, you can go to the Sigma webpage. I think that's kind of the landing page, and you can go into different places. We have an email list that you can subscribe to, and we have the dedicated page for our tools and reports and whatnot related to Sigma. And here's a map of the DWR regional offices. Depending on where you are, most likely you will be initially interacting with the people, even though you can't really read the names, but each region has a dedicated person for Sigma, so you'll be basically interacting initially with those people, depending on where you are in California. So that concludes my presentation.